Okay, welcome to the April 1st, the April Fool's Day edition of the Centre meeting for the Royal Astronomical Society of Canada, Ottawa Centre. I'm Bill Wagstaff, your Master of Ceremonies, I suppose. We'd like to take this opportunity to welcome everyone to the meeting tonight. I can't really see very well with the lights the way they are, but how many people are here for the first time? Yeah, I thought so. There's a whole crowd in the back tonight. So besides all the usual posers who have been here for 15 years and put their hands up, there really are some new people tonight. Well, welcome. We always like to welcome new people. You're welcome to attend the Centre meetings. You don't have to be a member. We always like to have people from the public come out and attend the meetings. Hope you find the material interesting tonight. Next, please. So, he's disappeared. All right. Hang on. Let's see if I can do this. Tonight's program. Okay, we're going to start off tonight. We did a real fast juggle here because we heard there were some newer people, and we thought we'd start off with the lighter material. Sorry, Rolf, didn't really mean that, but what is it? So we juggled the order around a little bit here, and the way we're going to run is Rolf Meyer, first of all, is going to talk to us about amateur astronomy communities. He's just back from a long trip into the U.S., and will be showing us some travel pictures. We're going to follow that up with observations tonight, so those of you who have slides in, be ready. We're going to start off pretty early, followed by Al Scott with our usual 10+ minute astronomy news. We'll see how we make out with that. And Mike's going to talk to us a bit about public outreach. We've been pretty busy. After the break, Richard Alexandrovich is going to give us a talk, followed by Chris, finally, is going to get a chance to finish off his two-part talk about iPhone and iPad applications. So without further ado, let's just jump right into it. And next, I've got it again. Okay, so Ottawa Rasc members in the news. So this time, seems like every month there's something. This time, Rob Dick, Citation Service Award. He's been awarded by the RASC National Centre for service to the city. Congratulations, Rob. Very much deserved. All the effort you put into service at the national level, very much appreciated by the membership. Going on from there. So we've got a little bit of a quick video. It's not actually done by an astronomer, as far as I can gather. It was sent in by Gary, if I remember correctly. Yes, thank you, Gary, by the way. I got fishing around this fellow's website, or his YouTube account. It goes by, what is it, Morn1415. I couldn't find out any information about him except he's from Austria. He does a lot of 3D rendering. You know, he does modeling in 3-space, synthetic shapes, and then he does a very complex motion video of these things moving around. So he's done one that basically gives you a comparison with respect to the moon of various sizes of stars. So without further ado, Chris, maybe away we go. So if you remember his name, go take a look at his whatever you call it on YouTube. He's got a number of other very interesting ones, not astronomy related, but mathematics and other fields. But pretty cool stuff anyway. So let me see now. I have a black slide. Ah, okay. So we'll get Rolf up here right away. You all ready, Rolf?
Amateur Astronomy Communities, Arizona and New Mexico. I'm just kidding, fooling around there. We missed the last couple of meetings because we were in Arizona and New Mexico for about a month. We took about 1,300 pictures altogether, which I will now proceed to show you. This obviously will have to be broken up if I indeed ever get around to showing it all. But to start out with, I thought I would share the areas that have been set up for amateur astronomers, particularly this one area in Arizona and New Mexico. And it's by no means the only such area in the Southwest, but this is certainly one of the better known and better run ones. This is the area that I'm talking about. Down here you have Mexico and New Mexico and Arizona. It's about 80 miles on each side in this square. Arizona Sky Village was one of the first. It started maybe 5, 6, 7 years ago, maybe even 8 years ago. And then there is another one just over in New Mexico called Rancho Hidalgo, and another one over here which is just starting up called Granite Gap. Now these are all founded by one man named Gene Turner, who made his fortune in Florida developing real estate, and now he got tired of that, and now he's moved on to Arizona and he's developed these areas. This is what they look like on a light pollution map. As you can see, they're in a pretty dark area, not quite the black, but they are in the dark gray, which is virtually as good as you can get. This area here is the Chiricahua Mountains, and then you can see Arizona Sky Village, Rancho Hidalgo, and Granite Gap. So I'll talk a little bit about each of them. First, you've got Arizona Sky Village. That was the first one that Gene developed in conjunction with fellow Canadian Jack Newton. And this area consists of 4-acre lots where they require a minimum 1,200 square foot house, and a house and one observatory building is allowed. At the moment there's about 20 houses altogether, and a number of houses and lots are for sale. There is also a timeshare available if you want to have it for, say, a few weeks of the year. There are also house rentals available, and that's what Linda and I did. We stayed in a house that we rented for about 2 weeks. But in addition to that, it's a vast area, and there's lots of land and building lots available outside the actual Arizona Sky Village. So there's certainly lots of opportunity to get land in a very dark sky. And this is sort of one part of Arizona Sky Village. Obviously, you can see that most people have domes. This is looking towards the west, towards the Chiricahua Mountains. And the next shot will be taken from up here where we hiked. And this is looking in the other direction. The houses comprising Arizona Sky Village are basically down here. You can see about 20 of them here. One we stayed at was this one here. You see what kind of architecture it has? No, of course not. Most of the houses in the foreground here are in a small village called Portal, which is just at the base of the Chiricahua Mountains. And this is actually a very bustling community, even though it's only 150 people. There's always seems to be something going on in Portal. For example, one night in the community center, Fred Espinac, who has a house in ASB, gave a talk about eclipses. He is a well-known eclipse photographer. So there's lots of stuff going on there. It's quite surprising. There's a grocery store, restaurant, post office, library. It's amazing. Next, you've got Rancho Hidalgo. This was the next development that Gene started in just over the border in New Mexico. Also about 4-acre building lots. However, the building permits are less stringent, and you can get by with well, there's less rules, let's put it that way. So I think the houses can be smaller, and they're not too fussy about what kind of house you have. Like, for example, at Arizona Sky Village, it would be frowned upon to have to just bring a trailer and plop down a trailer. However, at Rancho Hidalgo, they have RV sites available. So if you have a trailer, you can rent a site just for that. They're also doing some alternative building projects where they want to have some houses off-grid and maybe earth berm kind of houses. But it's more than that. It's an actual ranch. So there's horse riding, which we partook in, and there's planned to do rodeos, and there's basically ranch accommodation. So there's a kind of a bunkhouse there to rent a room. There's also a timeshare available, which is actually these are still for sale. It's also the site of Clyde Tombaugh's 16-inch telescope. Now, this is not the one he discovered Pluto with, but it's his own telescope that he built for his own use as an amateur astronomer. And it is a working ranch and farm. They have crops and they have cattle, and so it is a money-making operation of several thousand acres. And again, pretty dark skies. And this is some of the private observatories there. This one is Celestron. This one is run by Astronomy. This is Clyde Tombaugh's telescope. Here it's a 16-inch reflector. And this interesting thing here, this is a series of remotely controlled observatories. And I don't think they're all completed yet, but these are actually built by, we understand, from somebody in Newfoundland, or maybe the Newfoundland Center of the RASC, I'm not sure. But there's some Newfoundland connection there, and they're trying to actually rent these out. So it was interesting. We didn't quite know what they were until we asked around. And finally, we have Granite Gap, and I'll be talking a little bit more about Granite Gap with also a movie that I have of the rocket launching. This one is again, it's a little different. It's a little lower scale again. Sort of aimed at people who don't want to be permanently residing in a house. So there's a lot of RV sites available. And they have what I would call mobile homes available as timeshares. There's roll-off roof observatories where you can keep your telescope permanently mounted. It's a very ambitious site. They're planning to build a planetarium, a rock and mineral museum. There's an area for amateur rocket launching, an area for model aircraft. There's a huge man-made lake that they're going to have fishing. And again, it's several thousand acres. This is actually Granite Gap. This is the gap, not where the site is, but this is a mountain, which we figure is why they call it Granite Gap, because there's a gap between the granite mountains. These are the Chiricahuas. This is looking to the south, and Arizona Sky Village is over here somewhere, and to the left is Rancho Hidalgo and Granite Gap. These are the small mobile homes that they have available as a on a timeshare basis. They're about 400 square feet, but they have basically a living room, bedroom, bathroom, that kind of thing. And these are the roll-off roof observatories that they're building. And this is from the rocket launching site. One of the larger rockets that was launched. I'll be showing that launching in one of the videos. This one went up quite high. It was 6,500 feet, I think. And this is actually a shot of it rising. This is one actually a frame from the HD video that I made using an iPhone. And then these kids here with horses and cell phones, they were the recovery team, so they would ride out into the desert and retrieve the rockets. Yes, and just by coincidence, they had this rocket launching in conjunction with kind of a site dedication, and there were speeches given by various celebrities. This is, oops, didn't mean to do that. This is Gene Turner. He's sort of the godfather of the whole operation, all these 3 sites, and he has very ambitious plans for the whole thing. And you can just talk to him for hours, and he'd be listening to he'd be willing to listen to any ideas that you have. He's got a lot of people also working for him. I get the impression he's quite wealthy. This is Jack Newton, well-known Canadian amateur astronomer, and other people that spoke here were David Eicher, an editor at Astronomy magazine, Michael Bakich, Astronomy magazine, and David Levy. Okay, and I guess this is the movie?
Yep.
So this is kind of an overview of the site there, and where people were standing behind these barriers, and there's the blockhouse. This is where you would be sitting if you were to launch a very powerful rocket. And I guess also a clubhouse for people to keep their stuff. Where the area where they're preparing the rockets. I don't know if we're going to have the sound. I guess Chris is going to turn up the sound. There isn't really much to hear until the end, so. And where they're getting the rockets ready. That's Gene Turner as well. There's Jack, and this fellow's also Canadian. Adam, this fellow lives from North Bay. A lot of Canadians down there, by the way. These are some local kids, some local New Mexico kids that built they each built a small rocket. I didn't quite follow it down, but everybody else seems to have a good eye on it. This is a bigger rocket, and this one produced all kinds of black smoke. And this is where you have the kids going to collect the rockets, because they can climb through these barbed wire fences, and they don't seem to mind that. And they'll come back with your rocket. And Gene Turner actually himself launched a rocket. This is for some qualification exercise or something. I'm sure Bill probably knows a little bit more about that, but he had to launch this particular rocket to be qualified to launch them, I guess.
Yep. Probably level 1.
So this one was quite a nice launch because it didn't go too fast. I was able to follow it up, and you can actually still see it. Okay, now this one here is this was the biggest launch of the day, and so everybody is very attentively listening to his description of it. is saying that the altitude will be about 6,500 feet. Not sure what kind of an engine that would be.
Probably about a J.
A J, but maybe a J engine. 2-second burn. And for this one, people had to be pretty far back, so nobody closer than where we were there. And because we didn't know how well it could be tracked, everybody had to keep an eye on it. And it was fairly windy, but it didn't seem to be much of a problem to recover the rockets.
Holy shit.
Okay, so that's it, and over the next few months, maybe I'll have some more from that trip. Obviously, a lot of observations and a lot of other stuff that we saw, astronomy related. Okay.
Very good, Rolf. Thank you very much. Okay, well, we'll go right over to our observation reports, I think. Is this working now? No, it's still not working. I think we lead off with Paul Commission.
Tonight I'm going to show objects in the IC catalog. This is a kind of a junior brother to the NGC. They're both compiled by Dreyer, but the two supplements to the NGC, the IC catalogs, were in 1895 and 2008. There's 5,386 objects in the IC, the index catalog. Now these objects are usually not as bright or as well known as those in the NGC catalog. Therefore I thought that tonight I'd show a few sort of half-known objects from the IC catalog. The first one, IC 166, is an open cluster in Cassiopeia. Its magnitude is about 11.7. It's about 8 minutes by 8 arc minutes in size, and there are about 120 stars in the group. The brightest star, by the way, in the cluster itself is the 17th magnitude. This is also known as Tomba 3, Clyde Tomba, that Rolf Meyer talked about, the discoverer of Pluto. That he also discovered, I think, this thing, or partly discovered it, or whatever it is, this particular object, and as I said, in Cassiopeia. Next, please. This is IC 342. It's a galaxy in Camelopardalis. It's a low surface brightness object. It's difficult to photograph. You notice that although the middle is quite bright, the arms are fairly faint. It's also known as PGC 13826. That's thanks to Glenn LeDroux and the Desktop Universe. That is the only place I could find that. And the magnitude is 9.1 in the blue, and the size is 21 by 21. Its absolute magnitude is minus 20.4. The distance here is about 8.1 million light years, so it's fairly close as galaxies go. Next, please. This is 1590. It's an open cluster nebulosity in Cassiopeia. This is part of the Pac-Man. This is the inside of the Pac-Man. The Pac-Man has been shown here a lot of times on screen, but this is the inside part. It's also, the cluster is also known as Colinder 8. The magnitude of the brightest stars are about 9, so this is much brighter than the 166. And the distance is about 9,500 light years. Next, please. Now this last one, this is in the Cocoon Nebula. The Cocoon Nebula is around the center. The center of the thing is an open cluster named Colinder 470. Its membership is only 20 stars. But what I'm trying to say is that in a lot of these objects, the insides of them, you see a lot of this shown with the colored pictures. The large ones, they show the whole thing. What I'm doing in here is sort of going micro and going into the center of these objects. So you notice that oftentimes they're composed of more than one objects in various catalogs. Thanks very much.
Thank you, Paul. Thank you, Paul. So I found the disconnected cable, but once I got it done up, I apparently can draw an arc to my lips off of the microphone, so we'll maybe not use that. Anyway, Gordon's up next with his observations.
Well, as many of you know, I usually do sketching, but somebody that I thought liked me gave me a Meade LPI camera to try out. It's quite a challenge by times. Anyway, I did a couple of photos. This one is, this is Copernicus up at the top. Center is the?
Yep, center's the laser.
Okay, so this would be Copernicus up here. This would be Plato down here. I'm sorry I didn't invert it the right way, but anyway. The photograph was taken March 19th rather, with 120 mil refractor on a CG5 mount. And about the only processing is noise reduction. And then the next one, and this is Proclus over here. And again, you can see the sort of dragonfly pattern that the low impact craters tend to create. That's it.
Thank you. Good job, Gordon. Next up, Brian McCullough with a few seasonal observations.
Great, thank you. When Discovery, the Space Shuttle Discovery and the ISS were passing over on Discovery's last voyage, I ran outside with my camera, and you can see I was not working with a steady cam. But I got the image over on the right there, the larger image, as they were climbing out of the northwest, Discovery preceding the International Space Station. And then as they passed overhead and were starting to go down toward the southeast, you can see Discovery is the lower one in the image, and the International Space Station up top there. So just something a little bit different, but at least I got my souvenir shot of Discovery there. Okay, and we'll go to the next one. Of course, you know I focus on the moon quite a bit, so I thought I'd go for something a little bit different this time. So what I'm looking at is the Swan Nebula. It's number 17 in Messier's catalog of objects. It's also known as the Omega Nebula, and it's NGC 6618. Now it's located in the constellation of Sagittarius. So here we see this is normally would be a summertime sky, but if you get up, you stay up late enough, you can catch the summertime sky during the wintertime. So here's the teapot of Sagittarius down here, and the constellation of Scorpius with Antares, the red giant star here, and the hook of Scorpius comes down like this. So if you just climb up here, you're climbing right along the band of the Milky Way to where the Swan Nebula, M17, is sitting right here. It's a beautiful area to explore with binoculars. So we'll go to the next one, please. So we've zoomed in a little bit on it there. And you can see some of the other objects that are running right along the band of the Milky Way. And these are images from the software Stellarium. And over on the right, you can see that the image of the swan, it looks like a swan on a lake, except it's upside down in this view. So here's the bottom of the swan on the surface of the lake, and here's the swan's neck coming up this way. There are 35 stars inside the Swan Nebula. The nebula itself lies at a distance of about 5,000 to 6,000 light years. The nebula itself is about 15 light years in diameter. So there are 35 stars in there, and it's the energy of those stars that's making the gas glow into that shape, so it becomes an emission nebula. So I'll show you what I've done with this. All right. I'll tell you about the camera equipment just at the end there. So I want to tell you how it's inverted now. So now we've got the swan basically riding on the pond. Here she is right here, the base here. Here's the neck coming up like that. But what I wanted to do was really focus on the nebula part, the Swan Nebula part of it, and get rid of some of the background stars. So if we go to the next one, what I did was I established a dark frame. And if we go to the next one, and then what I did was I was able to subtract the nebula out of it and separate the nebula from the starry background. We'll get rid of the starry background now. I've just got the nebula left. So what I did was I went into Photoshop. I wanted to boost this a little bit. And if we can go to the, can you see the color in that at all?
Yeah.
It's a little bit odd, yeah, but I boosted the color just so I could get a bit more definition into it. And by doing so, it made an extremely strong image to observe. We can go to the next one. I was able to observe it right into daylight.
What?
Can we go to the next one, please? Okay. The camera equipment, I was thinking of using a Malin cam, but that was a bit too expensive for the likes of me. So I decided, okay, well, what else is on the market? So we'll go to the next one. Well, a Malin cam. But even that was more than I could afford. So I made my own, just like Glenn likes to do, a lot of people do, I jury-rigged my own, if we go to the next one, my own cantaloupe cam. If we go to the last one, please. That's an Australian. And I say thank you for his image and April Fools, everybody.
Thank you, Brian.
Yes.
Okay, next up is Terry Boyle.
Thank you, Bill. Well, here we are, Lord of the Rings, Saturn, beautiful planet. Who has never seen Saturn in a telescope? Never seen Saturn. Well, hopefully you will this year. Saturn will be at opposition on Sunday, which means it rises when the sun sets. And when you have both the Earth and Saturn to one side of the sun, means both planets are closest together. So best time for detail. In fact, I was lucky that particular night as I got part of the storm that's just dissipating up here in the north. Still, I got a problem with turbulence with planetary movement. Okay, next slide, please. Okay, next 4 slides are the moon. Here's Clavius. Clavius is this beautiful arc here in the middle, 231 kilometers from side to side. And because of libration is how the moon wanes and wobbles over the place, I was able to get the actual edge of the moon in this shot. Whereas other times when I've photographed Clavius, it's been higher, you don't really get the edge over here. It was actually processed in Photoshop. Before that, I used Registax 5 to actually merge the image. This is not a single image taken. Most of us, when we do lunar imagery, use a webcam or a melon cam or a TuneNet cam or whatever you call it. But it's actually a video. And using a software, Registax 5, which is free software, actually divides that video into individual bitmaps. Then you can stack the real good images, sharpen and play along with it, and that's how you get some pretty good detail. Okay, next slide, please. Next is Gassendi. Gassendi is only 114 kilometers from side to side. Not a very good night on this one. Depends how much turbulence in the upper atmosphere, but still the processing to try to get these wrinkle ridges, as Brian calls them, of course, detail within the crater itself. Okay, next slide, please. Next is Delisle. Delisle is just over here, but has some beautiful craters and even just mountains. The wrinkle ridges again too. The great thing about the moon is that it changes from night to night to night. It's actually the angle of the sun which depicts the scene. So if it was a full moon, you'd definitely not get this kind of imagery. But again, good detail that night around and even inside the crater. And next slide. The last one is Cirrus Iridum, 411 kilometers from side to side. Again, a good night of imagery, a lot of processing to pull out these little, pretty well 1 kilometer size resolution. And don't forget, the moon is about 390,000 kilometers from Earth when I took this image. So the moon's a great place to begin, great place to find. Even during the day, just like Brian shot, you don't usually see nebulae during the day. If you did, we'd be in a lot of trouble. But for those starting in astronomy, start with the moon and planets with the telescope. But the moon, you can just do naked eye or even with binoculars. Thank you.
Thank you. You're getting some very nice, almost 3D effects with the photographs these days. Just a few years ago, nobody was getting images like that. But really good now. So Doug, did you want to pop up for a moment? Is Doug here? No sign of Doug. So very nice high resolution image of the full moon here tonight. Okay, and on to the next. And who we got next? Rolf.
Okay, so what's special about March 26th? Anybody? Anybody? Not you, you know.
You didn't say a
Any-
word?
Anybody out there? What was special about? It was Earth Hour, right, right. So, was it any darker? Well, let's see. So here's the Pleiades, and here is M31. This is the zodiacal light, and the general glow in the sky, of course, is due to light pollution. This is Pakenham, and this is Arnprior, and there's a bit of cloud here scattering the light as well. So, how can we tell if this was darker than another night? So this was taken at a little after 9 o'clock, so I took another picture the next night at about the same time to see. And again, Pakenham and Arnprior and the general glow. So I don't know, I think it was darker, not at Earth Hour. So, I mean, the difference is, I don't know, that this was a Saturday and this was a Sunday, so maybe there's less lights on Sunday. There's more light scattered. Well, I mean, the atmosphere has an effect on how much light gets scattered anyway, so yes, light pollution makes a difference, but also the condition of the atmosphere. Really, the main contributor to light pollution is street lights, and I really don't think they turned off any street lights. So that's it. But it's a nice. So I should say Ottawa was directly behind me during these pictures. Okay, so but still not that far from Ottawa, so there would still be some influence from the general light pollution that you'd get in Ottawa, but certainly the darkest part of the sky towards the west, and fairly decent view of the zodiacal light anyway. Okay, that's it.
Thank you all. Food for thought, no? Apparently Earth Hour is not really having the effect it's supposed to have, but apparently the power utilities can measure the decrease in power consumption though, so there is some effect. But like Ralph was saying, it's mostly streetlights and they're not being turned on. Next up, Bob Olson.
Or museum lights.
Or museum lights,
Or
right?
museum lights as well, yes.
I just returned from Florida, where we were at the Winter Star Party, observing at 80-degree weather while you guys were having blizzards.
Names were called or referred to while you were away.
This is M100 from Florida, and I have to admit that I don't plan my observation sessions very well in Florida. Basically, somebody sees something down there, and then I go and image it, because I'm basically too lazy to plan. Beautiful face-on spiral, though. They were looking at this section of the sky with a 14-inch celestron mounted on a Paramount mount. It's a friggin' thing, weighs 400 pounds. And it was really gorgeous, so I lined up my scope on it and took some images, and then when I got home and processed them, I found out I was astonished at how many galaxies showed up in this photograph. So they're actually easier to see if you make a negative out of it. So I just reversed it. And then I thought it'd be sort of fun to find, what they were. I recognize the Messier objects, but the rest of them are, hardly anybody knows. So I labeled some of them. And the question marks are the ones that, again, I was too lazy to look up any deeper than Starry Night. But there is a ton of galaxies in that photograph. And it's part of the Markarian chain. Extends off towards, it doesn't show up in the white, this way. And these ones here are called the eyes, and they are under high power and good seeing. The view in Florida on the first night when I saw this was just outstanding. We could Saturn looked like the photographs. It was fantastic. And then the rosette was high in the sky, and I've imaged the rosette before, but it's so beautiful that I couldn't resist taking another image of it. This is a picture. This is actually a little cluster here that sometime I may image at a slightly higher resolution. And then at 3:30, I was up to 4 o'clock every morning for the 5 nights. And at 3:30 in the morning, Omega Centauri, which is very low in the sky, and I did not have a very good view of the southern hemisphere, of the southern sky. I was between trees. This here popped between 2 trees. It was blocked to the east and blocked to the west. And for about an hour, this thing hovered just over the horizon between these 2 trees. So I imaged it. And I thought, when I came home, I thought to myself, you know, it might be interesting to compare this size to our big cluster, M13. I took M13 when I got home with the same scope and the same setup to show the difference in them. This Omega Centauri is naked eye. You can see that naked. It's fantastic. One of the real highlights of going down there to see it. And then on, I think it was March 19th, was the moon got as close as it gets to Earth.
The supermoon?
The supermoon, yeah. So anyway, I happened to be out, so I wasted 5 minutes taking this picture. And I was actually trying to get my telescope to work again in Canada. Everything was set up for latitude 23 degrees. So it took me all night to do this. Anyway, the moon came up, and I thought, well, that's kind of neat. So I took a picture of it. Then I thought, well, you know, I'd labeled the other picture, so maybe I could label some of the things that I care about on the moon. That's all I know about the moon.
Bob, why are you presenting it upside down?
Oh, just the way it is. I wouldn't even know that it was upside down. Anyway, I also thought, you know, this is a supermoon, and what does it look like compared to the regular moon? Well, I just went back and found some images I'd taken earlier with the same setup to compare it, and it was, you know, it really was a supermoon. It was an incredible difference. And what I really was fascinated with, it was almost as big as Mars in August. Thank you.
Thank you, Bob.
Oh, that's great. Okay, well, that's enough of those shenanigans. Let's get on with something a little more serious. So to bring you the astronomy news, Al Scott. Al? There he is.
Okay, so now for the 10-minute astronomy news.
He took away the plus. You don't get it anymore.
Thanks. Okay, so the breaking news for this week. The Messenger spacecraft has arrived at Mercury. It was launched August 3rd, 2004. It's a NASA mission, and is the first spacecraft to orbit Mercury that we know of. And so it's now been sending back images. They had a press conference on Wednesday to release the first images from Messenger. They have a high-resolution wide-field camera and a narrow-field camera. So on the left is the first image sent back from Mercury orbit with the wide field camera, and on the right is an image of the northern plains about 100 kilometers on a side using the narrow angle. So this is from NASA, Johns Hopkins University, Applied Physics Lab, and Carnegie Institute of Washington. So I've just put together some nice pictures from the news conference, the first releases of some of the close-ups of Mercury. You notice it's really quite a bit like the moon, you know, very nondescript gray with lots of holes in it. But the resolution of some of these photos, you can go on the website and look at them as they're coming down. In the first 5 days of taking data, this spacecraft has returned more images than all of the previous missions to Mercury combined. And it's going to be operating for years, and it's going to try to map the entire surface at this high resolution. Look at this beautiful crater here and the symmetric rays coming out of it. Here on the left is some more of the North Polar terrain. They're looking to see if there's any ice in these craters, potentially in the shadows. And then this one on the right is crater WC. It's one of the bigger ones. You can see some of these things. You can see there are chains of little craters. And some of them you can actually see that what looks like debris streaks coming from the crater themselves.
Alan, are those photos supposed to be in color or black and white?
I believe these are in color. They have an 8-band imager, and actually they have an 11 filter visible imager. There's one that, for most of their images, they're using only 8 bands, but for some of them, for mineralogy, they're going to use 11 bands. And here's one here where they used all 11 bands on the left to look at the different rock types. You know, you got darker basalts and lighter basalts, mostly basalts. And then again, another one from the wide angle. So some neat pictures. You can go to the website. You can look it up. Now on to the next topic: dead stars and X-ray stripes. So this is a little more science, a little less of the pictorial wow. This is a discussion about cosmic rays. Now, cosmic rays are high-energy subatomic particles that come in from space and bombard the Earth and wreak havoc on computer systems in orbit. For years, scientists have been measuring these things, and they can measure the energy of these things. And they've seen some that are anomalously high energy, like these subatomic particles pack enough energy, the same amount of energy as, say, a 98-mile-an-hour fastball thrown by a pitcher in a subatomic particle. And nobody really knows where they get this energy from. No known event can efficiently accelerate these particles in the nearby universe. Some people thought, well, maybe this is from the Big Bang, but theories say that if they're coming from that far away, they'll lose their energy by colliding just with the photons in the intergalactic medium. So what this means is that these anomalously high-energy cosmic rays must be coming somewhere near our galaxy. And so this observation sheds a little bit of light on what the source of these things might be. This is an image of the Tycho supernova remnant. It's with NASA's Chandra X-ray telescope. So this is an image in X-rays, an extremely long exposure of this remnant of a dead star that exploded back in 1572 and was noticed by the astronomer Tycho Brahe. Scientists think the explosion occurred when a white dwarf star grew in mass and exceeded its weight limit, forming a type 1a supernova. So this is about 13,000 light years from Earth. The discovery here is a pattern of X-ray stripes that you can kind of make out around the perimeter of this thing. And this may provide the first direct evidence that cosmic events can accelerate particles to energies that are being detected in our atmosphere, 100 times higher than what's achieved by the most powerful particle accelerator on Earth, the Large Hadron Collider. One way to reach these energies, of course, would be to have extremely high magnetic fields arrayed in coherent structures larger than the solar system. And that's what this is evidence of. Now, the theoretical basis for this is not really well understood. Nobody predicted these coherent stripes, these tiger stripes in the supernova remnant. But theory suggests that the magnetic fields are amplified in the blast wave from the supernova. This is a ball of energy from a dead star in the middle, and it's expanding outwards. Magnetic fields are tangled, and the motions of particles in these blast waves are very turbulent. And it's kind of like what happens is that the magnetic fields trap the charged particles that become cosmic rays, and they spiral around these magnetic field lines. And every time they cross the blast wave, they get more energy. It's like a cosmic pinball, where the magnetic field lines are the bumpers and the shock wave is the flipper. And these things go higher and higher energy, and then they shoot out and come in and smack into our atmosphere. And so actually looking at this image, assuming that the spacing between these stripes is equal to the rotation frequency of the highest energy protons, this would correspond to something like 100 times the energy of the Large Hadron Collider, which is the most efficient particle accelerator that man has ever created. And it's not really so large in comparison, and is really equal to the energy of the cosmic rays that we are detecting on Earth. So an interesting discovery. And that brings me to the end of the scientific portion. Now I just have a couple announcements from the club, and for myself, we are still interested in looking for volunteers for a couple positions. at the club, a Smart Scope Observing Coordinator. We're looking for people that would help out with our robotic telescope, and we're interested in helping to schedule observations as it becomes operational later this year. And I'm also looking for someone to help out with the telescope loan library, which I run. And if you're interested in renting a telescope and you're a member, you can come to me, send me an email, and we can bring actual telescopes that we have that the club owns and rent them out for beginners or anyone who wants to try out telescopes. So get in contact with me if you're interested. Thank you.
Thank you. Thank you. And as probably most of you know, the center is very active in public outreach, contacting people who are not involved in astronomy and giving them their first taste, inviting them into the hobby. Here to speak to you about recent activities, Mike Mogadam.
Hi, everyone. Next slide, please, Chris. I'm going to talk about a couple of events that we had recently and some events that we have coming up as well. We've got quite a few things coming up. So particularly for those folks who are here for the first time tonight, if you're interested in these events, come see me after break. I've got a website I'm going to refer you to that'll give you more information, so you don't have to write down in the meeting here all the events. Okay. So it was last Saturday, we were invited by the museum to join them in celebrating Earth Hour. Next slide, please. And there was a outdoor star party. We brought our telescopes. The observatory was open. We had a fairly large indoor exhibit, and the museum as well had a large indoor exhibit. It was, it was largely about astronomy, so it was just a wonderful event. I was expecting maybe 200, maybe 300 people for this event, and click the next button. We were blown away. There were 750 people. It was unbelievable. It's just truly unbelievable. So I think for those of you who were here last meeting, you may remember me telling you that the museum is getting better and better at promoting events here. And next slide. And one of the things that they did was they partnered with Hydro Ottawa, and Hydro Ottawa, to benefit from the Earth Hour aspect of it. They promoted the event heavily and I know in schools in particular, my daughter received a pamphlet and she brought it home. She said, "Dad, do you know anything about this?" I said, "Yeah." so it was really nice to see that. She actually said she wanted to come too, so I was really flattering, but she didn't. By the way, she's got this image of me being here tonight with a bunch of these nerdy people. So one day I want to dispel all that, and bring her here. But some of the things that we had at the event were, we typically have at these events as a sign-up sheet. So for those folks who are interested in finding out more about astronomy outreach events, we have a notice, and it's pretty well received. That list is now 250 people that are on my email distribution list. Okay, next slide. This is a shot of the lineup to going to the observatory. So it's interesting that evening there, I was figuring that the only thing we'd see would be Saturn, but I forgot about Mercury. Of course, Mercury was just coming off of the eastern elongation, and so we were actually seeing some Mercury too, which was really nice before it set. But let me describe the bottom shot there. So we had a lineup of people that stretched all the way from the observatory right to the roadway, and it did a little bit of a hook. So it was unbelievable. Now you can't see it there, but actually we had about 5 or 6 telescopes that were completely enveloped by the people there. In fact, I was telling people, don't wait in the lineup here. You can go if you go a little bit further ahead. You can get in the lineups for see the telescopes and so forth. And that really worked out well. Some really good feedback. Although I have to tell you, we did not anticipate such a large crowd. Next slide. One of the things that Jeff Coyle does, which initially I wasn't too sure about, but it's very popular, is he shows some videos from speakers like Alex Filippenko, and they really are engaging. They get a group of typically people will come and they'll stay for 10, 20 minutes, which is kind of unheard of in these events because typically people go from one event to the next, and so forth. But Jeff's videos really they sort of snap people and they hold them. So well done, Jeff. Next slide. Our usual displays that we have we set up our main display, and next slide. And you can see in the background on the left side there, the museum brought their Starlab planetarium up front, which really worked out well. Those people there or the characters there are associated with Ottawa. Next slide.
Is that Astro Bear?
I don't know.
No, I didn't bring him, so.
And the bear showed up well. I don't have a picture of him, but our Jim Watson. But all in all, it was a terrific night. The museum, by the way, I forgot to mention, they actually turned off some of the parking lot lights, which really was good. So they can do it. And particularly they turned off the big floodlight, which I was really worried about. But they did it, and it was better. There's no question. Tons of volunteers. You know what? Probably could have used another half dozen telescopes. It was just overwhelming. So thank you very much, everyone, for that. It's just a terrific event. Okay, onward. Next slide. Something that just came up. We were recently contacted by the Canadian Space Society, the Ottawa chapter of that group. They're partnering with the Canada Aviation and Space Museum to celebrate the 50th anniversary of human spaceflight. It's 50th anniversary coming up on April the 12th of Yuri Gagarin. These folks are having a social event, including a panel discussion, and Al is one of the panelists talking about the next 50 years in space. They've asked us if we could set up an exhibit, no outdoor stargazing. I'm looking for 2 volunteers. If somebody who is interested in attending this event, let me know. So by the way, some of the groups that'll be there, there's some other astronomy clubs are going to be there as well. Telsat, MDA, some university groups. They're just trying to bring people together here. I hadn't heard if the CSA will be there, but they're trying to bring together a number of people, just a number of different groups in the Ottawa area to participate in this event. Looks like it should be a lot of fun. Well, something before I forget, something I want to point out is check out, you go tonight around the weekend, check out that URL at the bottom, Yuri's Night. So I didn't know much about this, but when I went onto that website, it's kind of hard to see. If you'll peek right at the bottom of the slide there, it is a huge global event, a celebration of the 50th anniversary of this first human spaceflight. Events all over the world, so I'm almost thinking it didn't really get as much attention. At least I wasn't aware of it locally here, but it sounds like it was. Lots of folks were aware of it elsewhere, that's for sure.
But you'd have to miss the political debate.
Yeah. Yeah, good point. Next one, please. Okay, so just for the benefit of those folks who are here for the first time tonight, we do have a free public stargazing schedule. I can confirm now that this is official. We've got approval from the city. We've got everything. We're all insured. Last time I told you that this was tentative. It's now confirmed. This is on our website. The website at the bottom, ottawa.rasc.ca. For those who are not familiar with how this works here, the main events are the dark bold events here. Okay, so the Saturday, May 28th, June 24th, and so forth. And the smaller font events are backup events in the event of cloud or rain. Okay, so if it's raining on the 24th, we flip to the 25th, June 25th, and if it's still cloudy or raining on the 25th, we have yet another backup date on July 2nd. And if that date is bad, well, we no more. We wait till the very next event. Okay, so I'm hoping to see you all there. Next slide. This is located in the parking lot of the car branch of the Ottawa Public Library. On that website, ottawa.rac.ca, we've got directions. It's right beside that Beefing Bunker site, so just down the road from the Carp Fair. Next slide. And again, this is free and open to everyone. So please tell your your work colleagues, your family, friends, school teachers, whatever. They're all welcome. You don't need to bring a telescope to attend. Come as you are. And again, we don't sell or promote anything. Special thanks to Stephen McIntyre for putting all of this together. It was really well done. So go from there. Okay, next slide. Another big museum event that we have every year, and it's another well-organized event, is International Astronomy Day. This is coming up Saturday, May the 7th. What we have in this event is there is a daytime solar observing, indoor exhibits, and in the evening it's a star party. Okay, so it pretty much stretches most of the day. There's a bit of a break in between for the daytime and the evening events. Very popular. We usually have a very huge crew from volunteer crew. If you haven't done this before and you're interested in participating, let me know. It's a lot of fun. We pretty much people come to us, and particularly when we set up our solar scopes on at the front entrance. We have people when we come in, and we have people. We greet people on the way out. It's a very popular event. So if you're interested in volunteering, once again, please let me know. I'm certainly looking for volunteers. I want to talk a little bit more about another event coming up. The Cube Gallery, Art Gallery on Wellington, they have an event that they is coming up, which has an astronomy theme. And what they're doing is they've asked us to participate in have a star party, host a star party. They're going to have some speakers coming to this event. There's a bit of a light pollution theme to this event. But the other thing I wanted to mention, I didn't mention it well enough, I think, in the last meeting, is that they've asked our members if we wish to bring our art, any astronomy art that we have, and actually sell it. They'll be receptive to that. So, and one thing they're particularly interested in is if anyone is interested in selling their astro photographs, they'd be really interested in that. So, what I would suggest is, well, again, contact me, and I'll give you the name of the fellow at the Cube Gallery. Actually, his name is Don Monet, and M-O-N-E-T. But anyhow, I'll give you the name. If you're interested, let me know, and I'll just direct you right to him. He's very, very keen on having a show of photographs. Excellent. Some of the things I got coming up here is I'm planning a solar observing schedule similar to the evening star party schedule. The thinking is that it would be at chapters in Canada. So these daytime events are great, particularly if you pick a very popular location. There's nothing stopping us from holding this elsewhere as well. Okay, if you're interested in, if you have some ideas on some other locations where we could have these events, please let me know, because I want to lock this in fairly quickly, post on our website, at least have a schedule visible to folks that can plan ahead and so forth. One of the things that I didn't succeed on earlier is I reached out to a couple of the malls and before Christmas, and asked them if we could set up displays and so forth. Now this was Christmas time, and so they didn't email me back. But I want to keep doing this, because I think it'd be great to you go to the busy locations and talk about our CARP Star Party program and so forth. So if you're interested and you want to get involved in the coordination of this, again, let me know. The other thing I wanted to mention as well is that we're in the process of just starting to redo all of our displays and posters and banners and so forth. I'm looking for somebody who's a lot more talented with artistically than I am. Maybe somebody's got a creative eye that wants to get involved in the design and maybe knows something about posters and banners and all this stuff, and who to places to make these things and so forth. So I'm really keen on that and getting going on that. So if you're interested in that, let me know. The other thing is I'm also looking for somebody who can help prepare some of the text for some of the photographs, and particularly somebody who's very gifted in French, who can help translate and so forth. Okay, I hear you, Sylvie. Okay, Sylvie, do you want to? I think that's it for me. Okay, one other thing I want to mention, really last thing here, is that we do have for our members an email distribution list. And I mentioned a couple of months ago that there's actually not as many people on this list as I had thought there should be. So if you're a member and you want to be notified about just about anything on our center, and you're not receiving these emails, then you're entitled to be part of this list here. So if you wish to be part of it, contact either Richard McDonald or once again myself, and easy enough to add you to this list. And and hear about events and send announcements and so forth. I think that's it.
know if you're on that list or not?
If you haven't received any emails in the last maybe from, let's say, Al Scott or Bill Wagstaff or myself about outreach events, if you haven't, you're not on the list.
But if you have, but
If you have received emails from myself, okay, then you're on the list. Okay, because I typically will send out a note about outreach events. Okay. And if you're not even sure if you are or not, let me know and we can look you up. Okay.
Yeah, Mike, sorry, we also have Facebook too. You can always advertise on Facebook.
Terrific. Thanks for mentioning that. That's a good point.
Mike, I'd also mention, if you do receive emails from the member list, like Mike's talking about, the subject line will start with square bracket Rasc-memlist. Right, so you'll know the emails from there.
thank you.
That's it for me, I think. Sylvia.
So Mike, next time you need something, you don't need to ask in front of everybody. Just send me an email. Well, yes, I'll do it. So what we need here is requests are starting to come in for school outreach. So I need volunteers for. I didn't do that slide, by the way, but that's pretty to the point. Volunteers needed. So what we need is perhaps some people helping with some demos, if we can, and if we have time to do some demos in the classroom. I usually can handle the presentation pretty well on my own, but some of them are around lunchtime or during the day, and they are interested in solar observing. And also there's a group of Cubs that would be interested into some star observing if somebody has a telescope that is mobile or has muscles that are able to move the one that we have with the club, the one that was donated to us. I cannot move something like this on my own. So anybody who's interested, you can come and see me personally. And compared to the other call for volunteers, this one is fun. It's with kids. Thanks.
Thank you, Sylvia. And up comes Richard Alexandrovich.
Good evening, everyone. I'm still going to be going into the Southern Hemisphere. If you can recall, a few months back, I did a talk on Omega Centauri, and I'll be talking about two other interesting objects, a lot of controversial issues regarding these two objects, the large and small Magellanic Clouds. I'll be referring to the clouds during the talk, so you'll know what I'm talking about, the LMC and the SMC. So astronomers have long assumed that Magellanic Clouds have been orbiting our galaxies for several billion years, but that may not be the case, as we shall soon see. One question that begs for an answer is, will they merge with our Milky Way galaxy or leave the local group never to be seen again? Both are one of the closest neighboring galaxies, and therefore they're easy to study. Only the Sagittarius Dwarf and the Canis Major dwarf galaxies actually sit closer to us. Next, please. Okay, that's a nice one. Okay, you have a list of all the galaxies here. This is not the local group. This is just neighboring the satellite galaxies around our Milky Way. As you can see, the list is getting bigger and bigger. And you can see the LMC, SMC were known since prehistoric times. You have all the other galaxies coming down if you want to take a brief study on that. And some of them are rather faint, so you can see that due to the technological advances, you can get more and more to see in the sky, not really far away, but just in our local neighborhood. These unusual galaxies are now under the astronomers' microscopes, or should I say at the far end of their telescopes, and they may hold the keys to understanding parts of the universe. Next, please. At declination minus 73 latitude, to the naked eye, they appear as two detached clouds in the southern skies. Don't bother trying to get them from up here. It would just be impossible. Both belong to the local group of about 40 or so galaxies. The large Magellanic Cloud is the fourth largest, only to be surpassed by M31, the Milky Way, and M33 in Triangulum. They are so near to us that the combined forces of the gravity has distorted the outer layers of our galactic disk, but we'll talk about that just later on. Next, please. Historically, they were known to the indigenous people of the South Seas, notably to the South Sea Islanders and indigenous Australians. Next, please. The first recorded mention was in 964 AD by Persian astronomer Abd al-Rahman al-Sufi in his book of Fixed Stars. In Europe, he was known as Azofi, and later renamed the Large Magellanic Cloud as Al-Bakar, or the White Ox. Next, please. The first recorded European account didn't happen until about 500 years later in a letter from explorer and cartographer Amerigo Vespucci. It was during his third voyage, from 1503 to 1504, that he made reference to 3 canopes, or 3 canopies, 2 bright and 1 obscure. The 2 bright ones he was, of course, referring to the both clouds, and the obscure one most likely, but not 100% sure, to the Coal-Sack Dark Nebula in the southern sky as well. Next, please. Several decades later, from 1519 to 1522, after circumnavigating the Earth, Spanish explorer Fernando de Margelis, or Ferdinand Magellan, was the first to introduce the Large Magellanic Cloud into Western culture. Just a word of note there, initially 237 men set off to sea and only 18 returned safely back home, so it's not like the luxury cruise liners that we have of today. One of them was Venetian scholar Antonio Pigafetta. I don't have his image, sorry about that. He referred to the clouds as dim clusters of stars, and it was during that time that both clouds were named after Magellan. Next, please. The Large Magellanic Cloud superstar status came in 1987 when the closest observed supernova since the invention of the telescope in 1604 was observed by astronomers worldwide. The event occurred near the Tarantula Nebula, the most active star-forming region in the local group. Next, please. In an astrophysical sense, physically speaking, the Large Magellanic Cloud lies about 160,000 light years away in the direction of the constellation Dorado and Mensa. It's sort of on the border. It is an irregular galaxy that has no obvious shape and has a prominent central bar and a spiral arm. Tidal forces from our larger galaxy may have influenced its contorted shape. In fact, the central bar is so warped that its ends are closer to the Milky Way than its central part. Astronomers have used Cepheid variables in the Large Magellanic Cloud to determine that the northeast portion actually lies closer to us than its southwest region. Scientists also have used red carbon stars to tell them that the disk of the Large Magellanic Cloud is both thick and flared. Finding the distribution of Cepheids and carbon stars led astronomers to conclude that the galaxy, from our vantage point, has an inclination of about 35 degrees. Next, please. The size of the Large Magellanic Cloud is only 1/10 that of the Milky Way galaxy. And we have a comparison there roughly. We try to get it as close as possible. It is also unusually low in metals, which makes it a good candidate for study. The galaxy, on the other hand, is rich in gas and dust, and therefore is the perfect lab to collect information regarding stellar formation. Next, please. The Small Magellanic Cloud, on the other hand, lying a little further at 200,000 light years from our home galaxy, is also considered as an irregular or amorphous galaxy that is also low in metals. To an observer, it is 22 degrees away from the Large Magellanic Cloud, or in reality about 75,000 light years through space. That is, if you're looking at the celestial sphere. Next, please. It is 10 times smaller than its sibling, or about 100 times smaller than the Milky Way. Both seem to be embedded in an envelope of hydrogen gas that is much lower, that has much lower density than either cloud. This envelope of gas is known as the Magellanic Bridge. Next, please. It is a rather peculiar that the low metal content and higher gas concentration within the two objects resemble galaxies found in the early universe. Galaxy evolution is determined by the quantity of gas, dust, and the amount of heavier metals that they have. But I would seriously doubt that there are strays from that earlier time period. It's just physically impossible. Next, please. What about cosmic rays? Well, both clouds explain the mysterious origin of cosmic rays. Do they originate from within our galaxy, or are they an artifact from beyond? If cosmic rays were detected throughout the universe, cosmic ray interactions in other galaxies should have been found. But when cosmic ray interactions were not observed in the SMC, a Small Magellanic Cloud, astronomers could then conclude that they came from within the galaxies themselves. They were linked to stellar events inside a crowded galaxy. So this is not a blanket universal thing. From our vantage point in the Orion Spur of the Milky Way, sometimes it can be difficult to observe a cosmic event. The proximity or the closeness of the clouds provide astronomers with a powerful tool when it comes to understanding the rest of the universe. What processes take place inside the two galaxies are mimicked in more distant ones. Studying both objects is analogous to observing our galaxy from the top. Next, please. About the supernova in the Large Magellanic Cloud, well, it was a surprise to astronomers. The progenitor star was a blue supergiant, but not a red one. According to stellar evolutionary models at that time, that is during the 1980s, a blue supergiant should not have gone supernova. So what probably transpired was that the two smaller stars had merged into one larger massive one. So two smaller stars melded its way together and then became one larger massive stars, and this, of course, set the stage for the cataclysmic event. Unfortunately, after 20 years of searching, astronomers have yet to find a compact object, whether it's a neutron star or a black hole, because during a supernova explosion, the object gets kicked violently into one direction, so it doesn't usually mean that it's at that specific point in space. For decades, scientists assumed that the two galaxies were gravitationally bound to our galaxy, scribing in elliptical orbit. In 2007, astronomers at Harvard University used data from the Hubble Space Telescope to determine that both clouds moved indeed much faster. Next, please. Their conclusion: the galaxies were likely traveling in a parabolic orbit that takes them near the Milky Way but once. This new data, combined with the original calculations, did not seem to jive together. It was becoming apparent that reproducing this bound elliptical orbit would be very difficult. And the $64,000 question. So where did the clouds come from? According to French astronomers, about 6 billion years ago, the Andromeda galaxy experienced a collision with another massive galaxy. This event created a long streamer of dust and gas that was drawn out of M31 and then ejected into extragalactic space. Next, please. I have used this image of Stephan's quintet to illustrate what I'm trying to refer to here. The streamer of dust and gas is called a tidal tail. It is created during a merger or collision, if you were, between two large galaxies. So you can see a tidal tail on the right reddish galaxies. They're sort of looping outwards, and this is what may have happened as it was ejected far enough as to come to our galactic neighborhood. Over time, this tail formed the two clouds and sent them heading our way. It was a startling revelation to the astronomical community. There were decades of numerical modeling involving the physical interaction as well as the processes between the two clouds and our Milky Way galaxy, and they were thrown out the window. It was long theorized that the warped disk of the Milky Way resulted from the gravitational forces of their occasional passes. Now, another explanation will have to be looked after, or another explanation will be needed. What about the intermittent star-forming episodes in both galaxies? This would happen if the objects moved around in an elliptical orbit. As they swung in close, the encounter would trigger a wave of star formation. But in a parabolic scenario, star birth should occur only once, not several times. If this scenario happens to play true, then we will never know their fate and they will disappear into space. A subject minor in controversy relates to the Magellanic Stream, and we're going back to the next picture. It's the same one. I'd like to use this one again. Known since the 70s, this artifact spans at least 100 degrees in the sky and consists chiefly of hydrogen gas. Of course, don't try to see it, it's invisible. According to astronomers in Australia, they've noted a finger of gas that lies opposite the stream and appears to puncture the Milky Way's disk. It is about 70,000 light years from our solar system, and from our vantage point is located near the Southern Cross. Scientists speculate that the clouds will be consumed by our galaxy. Of course, they will be powered by gravity. This is one theory. The Magellanic Stream may have been born when both galaxies passed near each other, causing starbirth and a chain of supernovae events. The ensuing activity caused streamers or tendrils to blow out from the stream. Fortunately, or the good news, is that the origin of the stream is not associated with our Milky Way galaxy. Next, please. So for now, we as backyard observers can agree that we can gaze at the Magellanic Clouds and tell ourselves that we may be looking at pieces of Andromeda that are swinging by our galactic neighborhood and may never be seen again by our descendants. This is indeed the golden age of astronomy, so make the most of it. And so, folks, there you have another episode in the ongoing saga of galactic evolution. That's it. I'm done.
Thank you. Well done.
Thank you, Bill. This is, as Bill said, a continuation of a talk that I started or tried to make here 4 months ago, and I managed to get half of it done 2 months ago. And we'll see if we can get the rest of it done tonight, unless the big hook comes from one side of me and says time's up. Sorry. There's been a huge explosion in the last few months in the kind of applications that are available on these really popular new platforms. I think a lot of applications were written for astronomy on the iPhone, and then the iPad came out and is so much larger than the iPhone that it's become a really outstanding platform for both being so bright and visual and large and yet so portable at the same time. And if you simply go to the Apple websites and the iTunes store and do a simple search on just the word astronomy, you now get 398 different astronomy apps for the iPhone, another 139 for the iPad. They're not all serious astronomy programs. Some of them are games, but it gives you a hint that it's obviously become a very popular use for these applications or for these platforms, and very useful for astronomy. I'm not going to try to repeat some of the detail that I covered in the first talk, but a very quick summary is that there's 3 components inside most, but not all, iPhones and iPads that make it so useful for astronomy. And that is, most of these have built in a GPS, which is giving you your exact location and, equally important, the exact time. There's also a built-in digital compass that tells you which way you're pointing when you have the iPhone. And there's an accelerometer that tells you at what angle you might be holding it relative to the ground. And if you combine those 4 pieces of information, it means that the iPhone and the iPad at all times knows exactly where in the sky it's pointing. From there, it's pretty obvious how you can then make use of computers and get some really useful applications in astronomy. I then took a lot of those apps and just started finding ones that I thought might be of interest to a group like this, and put my own sort of categorizing together, put them into 4 different categories. The most obvious ones deal with planetarium programs, and that was the subject of my last talk. And I only got through 4 of this list in my entire talk last time, but I went into a lot more detail because they're really the primary functions that you might want to use on an iPhone. But there's still a lot more things which I'll try to whip through much more quickly. So that you don't have to try to sort of take notes of which ones might be of interest to you. Oops. I do have here, and this will be my last slide I'll talk to at the end of the talk, but I do have a list of all the ones that I covered in part 1, and again I'll cover now, and that's here on paper as a handout if you want to pick it up later and remember what some of these names that I'll be flying by. But just before I completely pass up planetarium programs, I did want to mention 2. This one did not exist when I gave the talk 2 months ago. I haven't reviewed it. I don't know it in detail. I'm mentioning it here for one reason only, and here's some samples, screen captures of what it looks like. The reason I think it's important to mention to this group, it's one of only 2 apps that I'm familiar with whose roots is in a well-known planetarium program for computers. So if Redshift is a program that you know and like on a computer, it would be a natural one for you to then want to use it as an app. But as I say, I haven't gone into it in detail to see how well it works. And then there's another disappointing one. Google Earth has an app for the iPhone and the iPad. Works beautifully, looks and feels just like the full Google Earth program that you're accustomed to onto a computer. But if you are on a computer, you probably know that there is a function in Google Earth called Google Sky. It's actually quite a decent planetarium program. And when you get the Google Earth app for an iPhone, an iPad, it's not there. So nice opportunity. Maybe it's coming, but don't try this one. It doesn't work. So let me move from the planetarium programs to some just general observing programs that aren't trying to cover the entire sky. And the first one, called Solar Walk, for those who saw my first talk, made by some of by the people who made one of the finest programs in planetarium, and it fits into a whole series of programs I described that I consider to be extremely sort of visually rich, fantastic for non-amateur astronomers who simply want to know what's up in the sky when they look out. It's not full of the tools that more serious amateur astronomers might want, but it's extremely rich visually in explaining the solar system. It starts with a screen like this with, nice to see, 9 planets still in a brand new program. And as you touch on any one of those planets, you're taken on an animated 3D tour through the solar system until that object is at the center of the field of view. And at any time in here, you can use your finger in the typical way of an iPhone or iPad and rotate the view up and down. You can see it as seen from Earth or seen from above, zoom in, zoom out. And then as you touch on any one of them, you get a lot more information. Here is touching on Earth. As you zoom in, you'll actually see various cities, and in this case, it's showing the prominent satellites that are orbiting in real time. And you can't possibly, I don't think, see it from your seat, but they're titled, and that dot right there is the ISS at the time that I took that screen capture. Where it is of some use to us in amateur astronomy is that as you zoom in on the large planets with a large number of moons, you're getting a 3D view in real time of the various moons. So as you look up at Saturn and Jupiter, you not only see what the moons are, you can rotate the view from above to understand where they are. You can rotate the view as seen from Earth to understand where they are left to right, and you can set it in motion to see how quickly they're moving through the night. So interesting for identifying the moons. Here's an example of seeing it from above, so you understand the orbits, as opposed to seeing it edge on as we see it from Earth. Again, as you click on any one of the solar system objects, you can hit an information button, and lots of information comes up about the object, where it is in the sky, the typical kind of astronomical data about its mass, its diameter, its orbit, and so on, as well as information on its internal structure and late breaking news on the object. Now move to the next, and to me, maybe one of the finest programs. If I only had 2 programs on my iPad, this is one of them, referred to, as you can see, Moon Globe. And just to repeat a bit of what I covered in the first lecture, but I'll do it much quicker, you can see here on this screen the relative sizes of an iPhone and an iPad and what an enormous difference it makes. But you have to be careful when you buy these applications, because some of them are unique to one platform and the other. And they all tend to come out first for the iPhone, but here's an example of one that has been released specifically for the iPad, so it's not just the same image on an iPhone enlarged to the point of even being fuzzy, but a program that truly takes advantage of the large screen size and the better resolution. So let me show you a bit about how Moon Globe works. On an iPhone, here's 3 different sample screens that you'd expect to see, the one on the left being the obvious one, a picture of the full moon with various craters identified. And across the top, you see a sliding bar where you can control what phase of the moon it's in. You can also go in and set whatever time you want or set it in motion. But as you can see, as you move the slider back and forth, it's reproducing the proper phases of the moon and where the terminator is at any specific time. As you pinch on the screen and zoom in, You see here the kind of detail, and what's nice about this program is it's not just, when you zoom in, it's not just the same image being enlarged and becoming fuzzy, but as you zoom in, you actually get some pretty high resolution images of every part of the moon. And then as you zoom in, it knows to turn on more and more details, labels for the objects you're looking at. As an extensive catalog of the various features on the moon, which you see on the left-hand side, and as you click on any one of them, it then zooms into that object and shows you more and more detail about it. And it also has a catalog of every man-made mission that's landed on the moon and where those landers are currently located. But here you see what happens when you move to a much larger screen. You get much larger, much better resolution images, a lot more that can be seen on the screen. And again, the same idea as you move the scroll at the top, you change the various phases of the moon. But this is, I want to demonstrate what I think is fascinating about how well it shows the phases of the moon. I've zoomed in here on an obvious prominent part of the moon, but I want to draw your attention to Archimedes. You could equally look at any of the mountains and see what I'm about to show. But you notice here clearly the shadowing on the edge of the crater, and clearly the illumination is coming from the left. And as we move the slider at the top here, I'm going to fade it into the next phase of the moon, into the full moon. And watch what happens. You know, it's not just a matter of that they've applied a dark mask to the moon to show which part's in shadow and which isn't, but it's I think very realistically portraying what the shadows would be as it's illuminated from a low angle, or here as it's directly illuminated in a full moon. And as we move the slider across, the shadows accurately move. And that was not a motion. That was just me fading from one to the other. But if you were to do it slowly, you'd see the first tiny bit of shadow coming here, and then the shadow getting longer and wider as you go. So, and again, the same thing happened on all of the mountains here. So, very powerful.
You're saying that all this shadowing is happening or handled very dynamically. It's not just a sort of a crude series of steps of images.
That's what I believe.
Okay.
Yeah, very impressive. Again, on the large screen, as you zoom into particular objects, getting some pretty high resolution images for a little portable device you're going to hold in your hand while you're out in the field.
What are the sources for the photographs?
I don't know. And to repeat what I said before, here's an example showing Apollo 17 and exactly where it's located. A location probably well known to people, but all of the different lunar missions are located there. How many people recognize these craters and these names?
The backside.
This program deals with the moon as a full three-dimensional object, and you can see the backside. You can rotate the view so that you see it from above, from below, and you get to really see the huge impact craters that we don't appreciate from Earth because they're on the tops or bottoms or sides of the moon, but you can see them face on and by rotating this in any orientation you want. So impressive program. The same people have the same program available for Mars. And by the way, I didn't mention at the beginning, most of these programs I'm mentioning I have here with me on an iPhone, on an iPad, and you're welcome to come and see them and play with them. But yeah, the moon people also make the Mars globe, and then other people have similar programs for Jupiter, Mercury, Venus, and Saturn. So each of these is a separate app and readily available.
Will the iPhone apps run on an iPod?
An iPod Touch, yes. Yes, not an iPod, but an iPod Touch, yes. Yeah. Yeah, I keep referring to the two platforms, but I really should be referring to all three. Then a brand new program that's just come out, caught my eye, dealing with the outer planets. Caught my eye particularly because it comes from Software Beast, the manufacturers of the well-known program The Sky. I think you've seen a fascinating talk that Simon Hamner gave of one of their three-dimensional programs that takes you on tours of the solar system. So I said, this app's going to be fantastic. That's the entire app. a picture of Saturn and Jupiter, and a sliding bar that shows you the moons going back and forth, and lets you view it from above and from face on. That's an app that I would refer to as maybe it's in version 0. It's not ready for release, and it was quite pathetic. I was really disappointed when I found that. Again, I found an app that said this should be fascinating, one specifically oriented to the Messier list, which we all enjoy so much in astronomy. I look at its opening screen and say, well, it starts at least being very visually rich. This should be outstanding. Is that the hook? I don't have too much left. It starts, as most of these planetarium programs do, with a full catalog of all of the Messier objects, typically highlighting which ones are visible at that time and which ones are below the horizon. You click on any one of them, and you get, again, the typical screens that you see in any of the planetarium programs that give you the basic data about the object, interesting description, usually some very nice, pretty pictures. But those 3 screens you can get in any planetarium program. You don't have to have one specific to the Messiers. So I expected to see then, after that, a sort of a guide of where would you find these. This would be a natural app to build in a planetarium program, show you where they are in the sky, maybe add Tellerad circles around them, finder scopes. None of that was in the app. It was simply a listing of data, and if you want to tick off on the right that you've seen it, you can do that. But in the end, I was very disappointed that it really wasn't too useful and didn't provide anything that you don't get in a basic planetarium program. Then I found the NGC list. Again, this should be outstanding. That's the entire app. There is a wheel that you scroll up and down to the proper number, and that yellow text is all that changes from one object to the next. Useless. Where's my handout? Well, it's free, and that's what it's worth. The Messier one was also free. I think that they're a work in progress with lots of potential, but it's not there yet. So that covers what I refer to as sort of the observing apps, and the 2 first ones I mentioned are the ones that I think are really worthwhile having. The others were either of more limited use, such as Mars, Jupiter, or next to useless. Then I'll move into to satellites. A small, specialized app, but outstanding. Back to basics of the iPhone, it knows where you are and what time it is. And as soon as you open this app, it knew I was in Ottawa. This tells you, I guess, when I opened. No, you don't. Yes, I opened it for my first talk in the first week of January. And at that moment, there were the satellites due overhead in Ottawa that evening. Nice coincidence that the first one was the ISS. You click on it, and here's the details. Here's when it's rising, where in the sky, what its elevation is going to be, magnitude, and then interesting screens of data about each one of these satellites that's visible. But an extremely useful, just one click on the app, and you know what's overhead tonight and exactly when and where it's going to be. There is a second one that very similar by the makers of one of the great programs I showed in the first part, Go Star Watch, but here goes Sat Watch. Very similar concept. It knows your time and location, gives you the list of satellites that night. But in this case, instead of giving you a lot of data on the satellites, it's giving you a cute map of the world to show where it is, but more interesting, a very simplistic view of the sky from your area and where you expect to see the past to be. If you want the fine detail, it's in this small text here of exactly when it's going to rise, where in the sky, how bright, and so on. So 2 very limited use, but very useful, interesting apps for a phone. Then I'll move into the final ones that didn't fit in my first 3 categories. NASA has an outstanding app, really strongly recommend, and I'll show you different components of it. It starts, like many apps, across the bottom with the various screens that you can choose from, but the first one deals with their missions. And there is a list, I believe when I counted it, some 80 missions are covered on this list. And as you scroll down through the various missions, I happen to focus here on James Webb Space Telescope, large amounts of data and links to the NASA websites of all the information you'd want on that mission, particularly appropriate for missions that are happening, such as the space shuttle flights. You'd get up-to-date information right on your phone of what's happening with them. Then as you move to the second of the main screens, vast photo library that's available. That has 3 different sections. The first one you see up here is IOTD, in other words, the image of the day from NASA. And when I did this screen capture, 1,500 images of the day were available on the app. Then APOD, they have the full catalog, 5,400 APOD images online. And if that's not enough, you go to the NASA images, and there's only 147,000 images available through here. I have actually used this app to help 1 or 2 speakers here that wanted to find a video clip on a certain mission, and I found it easier through this app than even going to the NASA website. So really, really informative. It has an ongoing news feed of all their news releases, and then, to me, kind of off subject from everything it's about, it squeezes in visible passes of the ISS for your location. I don't know what that has to do with NASA, but again, there's ISS sightings for the day that I did the screen capture for Ottawa. If APOD was of more specific interest, they have their own app, and the full list of the full catalog of APOD images are there. And for every one of these images, if you click on it, it then scrolls into the extra data that APOD publishes for every one of their images. Sky and Telescope, well known for a website that they host called Sky Week, and they've simply converted it into an app. So if you want to go in at any point, they give you a listing in text here, linked with a full planetarium program to show you what they think are the sort of the feature objects in the next week in the sky. So very interesting. But actually not a bad little planetarium program that you don't have to use it just to see the image or the object that they're talking about. You can then go and use it as a simple planetarium program as well. Here's an obscure one. I don't know what you'd use this for, but it's fascinating. Exoplanets. As soon as you touch this screen, it goes to the internet and updates to the latest list of exoplanets that have been discovered. When I updated this earlier today, it went from 516 to 538. Gives you a list of all of the known exoplanets. You click on any one of them, and this is an animated version. I can't animate it on the screen here. That shows you the actual path of the exoplanet across its host sun, and then shows you the light curve that's produced by it. Shows you where to find it in the sky, and then pages of data about the exoplanet. All the data you could want over here of its discovery. And then a fun little tool, again, I'm not sure how useful this is, but it was fun to play with. They give you a list of all the data that they have and let you graph any 2 of the data that you want. So I picked a simple one. When was the exoplanet discovered, and what's its mass? And an obvious chart comes out. There's one of the first discoveries, a large object. As we move across over time, each of these vertical bars is getting denser and denser, so it's not just a few exoplanets. It's now a huge number of exoplanets, and over time they're getting smaller and smaller. I haven't tried to update that. I'm not sure what you do with this app, but it was fun to play with. Real utility for those who are caring about astronomical time. A utility that's telling you at all times local apparent sidereal time as well as coordinated universal time, either for your location or any Latin long that you want to input. And the last one I'll cover, Clear Sky Clock, not an app, but who says it has to be a formal app? Actually extremely useful on these 2 platforms. I don't need to describe Clear Sky Clock to any of you. I'm sure you all know it well.
Chris?
Yes?
There is an app.
Fantastic to be corrected. I'll
Seriously.
There is?
On my machine since I bought it.
And yet, quick question, why would you need an app when the full website is fully functional on the iPhone and the iPad?
When you're stuck away someplace where you download your information and then you go someplace where you don't have access to 3GS.
Excellent. Is it much different visually than?
You can zoom in and zoom out so that because it doesn't fit very well on the small screen necessarily.
Well, here's an example of what happens on the small screen. Here are actual screen captures from an iPhone, and where you might think that famous chart that we all use is a lot of data to squeeze on a tiny little screen, as you can see here, it's actually extremely legible. And as you click on any one of the squares to see what the weather map is of that's being portrayed there, again, completely legible. But you go to an iPad, and it's enormous. Now take that iPad and rotate it and zoom in on the chart, and it's that easy to work with and that large. The bad news, this is today. If Tim Cole was giving this talk, you know how he would end it on that screen. Another typical day in Ottawa, and what do we see is white. So back to the first slide that I showed you. Here is a list of every app that I've covered over the 2 talks, listed down the left. I've bolded the ones that I thought were the most interesting, and if I didn't have a lot of these apps for the sake of doing this talk, they're the ones that I would likely have here. And then I'll just cover the concepts in this chart without reading through each of the numbers. You can see many of the programs are free. Some of the free ones, as I've said, are garbage, and some excellent ones are free. That Moon Globe program for the iPhone is free and extremely useful. As I also said, you have to be careful when you buy these because there's many flavors of them. Some of these programs, as you see, if there's a price in this column here, are specifically for the iPhone and do not likely work on an iPad. Some have a separate program for iPhone and iPad, and others, like the Sky Safari, has both versions of their program work on both platforms. And when you see an example like this of 2 prices, typical reason is $2.99 is the Lite program, which is everything you'd want in a planetarium program, except the upgraded version for $15 includes telescope controls. Typically, that's the feature in the 2 programs here that have high-price versions, is that they have full telescope control built into them. But many of them are now, more and more, are working on both platforms. And the bad news on the right-hand column, I've been searching. None of these programs exist for BlackBerry, and nor could I find a useful program for BlackBerry. I think that may change rapidly with the new tablet that they've come out with, but at the sort of cell phone, smartphone scale of things, there's next to nothing there. When I gave this last talk, 2 questions were asked that were excellent, that I'll try to cover off here. There's a missing column, which I haven't tried to do any research on, and that's the Android. And in fact, Hugo, I think, answered me and said that there are now the beginnings. I think there's a half dozen astronomy programs or so that are coming out in Android, so there may be more coming there. Another good question that was asked by someone, some of these are really outstanding apps. While they're specific to phones, can you get them on an Apple computer? And the quick answer is no. They are apps specifically for the phone and the iPad, and they will not run on an Apple computer. And that's it. Finally got the second half of the talk in.
Good job. Thank you much. Oh, and that answers my other question. I was trying to figure out what I did with the other microphone. Now I know. Okay, so that pretty much wraps it up for tonight. Just a reminder again. Ron, where are you? Oh, okay, Ron's over there. I talked to you already before the break about the FLO key renewals. If you're looking to renew or to get a key, Ron's the one to talk to. He'll be outside after the meeting's done. Next, please, Chris. Okay, Stell's pick of the month for the Stanmont Book Library. Turn left at Orion. It's basically a compendium of 100 suggested night sky objects to see in small telescopes, and it's got a bit of instruction. So it's a good beginner book for those of you who haven't done a lot of observing before, have just gotten a telescope, an excellent choice. So if you're interested, the library is open, and you can drop out and take a scan, perhaps borrow something. At the same time, I will remind, we have been getting after people the last little while. Those who have books that they've taken out and they've had for maybe a year or 2 or 5, It'd be kind of nice if we got some of those back so others could borrow them. So this is your last anonymous warning. Next time I'm going to flash up a slide with names on it. So be forewarned. Okay, next please. Okay, so tonight, just after the meeting, Estelle has the book library open. Al, do you have the telescope library open? Was that a yes or no?
If someone's reserved the scope, I'll have it.
All right, okay. So Al for the equipment loan library. Art and Ann Fraser will have coffee, conversation, soft drinks, that sort of thing. Up front, as usual, you can see Art, who probably is wearing a dark blue sweater with Saturn on the back. He usually is. About membership information. Memberships are generally purchased off of the national website, rasc.ca. So if you need to renew or you'd like to purchase a membership, then that's the place to go. When you've purchased a membership, the membership card will come back to Art, so you pick it up from him when they come. We used to put them in the astronauts, but there's hardly any astronauts being distributed anymore. They're going the way of the dodo and other things. So just talk to Art. He'll have your card. It's usually within a month of when you renew. You can see Stephen McIntyre. Is Stephen here tonight?
No.
No? Okay. Well,
Sure.
whenever he does turn up, what is it? There are discounted magazine subscriptions available for Sky and Telescope and for Astronomy Magazine. You can see Stephen. You can probably find his email on the center's website as well. I'm pretty sure it's
Yes,
available.
and you can do it all by email with him. You don't have to see him in person.
Yeah, that's right. Just a reminder, the remainder of the museum, other than the front area, is closed tonight, so please don't go wandering. We like to keep our hosts happy, so we don't have to do this in the parking lot. And as usual, small get-together, members getting together for drinks, snacks, that sort of thing, over at Kelsey's across the road. So how many people tonight, Chris? Oh, 112. So down a little bit, I'd have to say. Oh well, I guess it was my absence. People decided not to come anymore. So, yeah, undoubtedly, undoubtedly. Yeah. So many thanks to the organizers and the speakers tonight. I won't go over the entire list, but you know who they were. And many thanks as well to our host, the Canadian Science and Technology Museum. Without them, we'd be in the parking lot, of course. So any complaints, comments, suggestions, anything else, my email address, bill.meeting.chair@gmail.com. Lots of dots in there. Thank you very much. Next meeting. Thank you. Next meeting, May 6th, 8 p.m. as usual. Be there or be square. Have a good, safe drive home. Good night.